Greetings, Internet. My name is Kevin Kennedy, and I am a math instructor at Athens Technical College, and I have a master's degree in math. And I know what I'm talking about. I'm not, your average schmuck off the street. And today, I want to talk about something that's very, very important to me, because I see it all the time on social media, particularly Facebook, and it's people getting order of operations problems wrong. And so, to be a little bit more specific, what I'll see is a problem like this, right here, and my mom, usually, has posted this problem on her wall. It says this caption is like 90% of people get this wrong, and that's horrible. It's an epidemic. It needs to be fixed. And the reason why people get it wrong is because they're not doing it right, because they're not following the order of operations. The reason why people get this problem specifically wrong is because they'll try to do it from left to right, because they're not thinking about it. Okay? If you do this from left to right, now keep in mind, this is the wrong way to do the problem. Okay? But if you do this from left to right, what you're going to get is 14 divided by 7, which becomes 2, this other stuff, which becomes 9, and this other stuff, which becomes 63, minus 7, which eventually becomes 56. All of this is wrong. It's bad. It's not good math. Okay? So, obviously, the question is, well, how do I do it properly? So let's take our problem again. And this time, we're going to apply the order of operations. Now, if you do not know the order of operations, the acronym, mnemonic, that I use for it is PIMA. Now, if you do know the order of operations, then you usually think about it as being PEMDAS. And we'll get to that here next. Okay? PIMA means parentheses, exponents, multiplication and division, addition, and subtraction. Okay. Now the reason why it's PIMA and not PEMDAS is because multiplication and division is the same step. Addition and subtraction is the same step. If you were taught it in high school as PEMDAS, your teacher probably didn't know better. I'm not going to say your teacher was bad, because I believe that most teachers have the best of intentions, but most people don't realize that that actually makes a significant difference, and we'll see an example like that after we do this one. So what this means is that anything in parentheses we do first. Then we do any exponents. Then we're going to do multiplication and division in the same step. Okay, that's important. Then we're going to do addition and subtraction in the same step. Okay, so this problem, if we're going to do it properly, what we really need to do is these two guys first. What it's going to give us, 7 divided by 7 is 1. 7 times 7 is 49. Like that. Then, we're going to do our addition and subtraction. And when we do operations that have the same priority, we're going to go from left to right. So, we're going to get 8 plus 49, which gives us 57 minus 7, which gives us 50, which is the correct answer. Okay? So let's see another example. Let's see one where this part is important. So, the next example I want to do is going to be a relatively simple example, but it's a good illustration of how that part goes wrong if you're using PEMDAS. So the problem I want to do, and again, this is a problem that I've actually seen show up in my Facebook feed from my mom. Bless her heart. So in this case, we're going to do a parentheses first. That comes first with our order of operations. So we're going to get 6 divided by 2 times 3. At this point, what we do next is really, really important. We're going to be doing multiplication and division, but we're doing them at the same time. Okay? The mistake that people make is because they're thinking about it as being PEMDAS, where multiplication is before division, is they'll do this part first. But the important thing is that multiplication and division are the same step. Okay? So, we're going to do the 6 divided by 2 first, because it's part of that same step. And 6 divided by 2 is 3. We do 3 times 3, which gives us 9. Now I want to do one more example, and then I want to have a talk with you about calculators. So the last example I want to do I have to make space. Alright, now, in this case, we know that we're going to be doing our multiplication and division first. So we're going to be doing those guys. And that's going to give us 9 minus 5 plus 12 plus 3 minus 30 plus 1. That is not a 1. Plus 1 minus 1. One thing I want you to notice here, if you haven't picked up on this already, as I'm doing these problems, I'm rewriting the entire problem. Far too many times I see students who try to do these problems and they'll try to do it without having to rewrite everything. And this is not just something I'm doing because I'm showing it to you. Okay? This is something that I actually do. Me, the guy who's been doing math for about 2/3 of his life. Okay? Which is about 20 years. This is something I do in practice because it helps me avoid making mistakes. Now, at this point, we're going to be doing addition and subtraction. But if we do the addition first, we're going to get it wrong. We have to go from left to right. So we're going to start with 9 minus 5, which is 4. And we're going to rewrite the rest of the problem. Okay, then I'm going to do 4 plus 12, which is 16. And we're going to rewrite the rest of the problem. Is it tedious? Yeah, a little bit. But it's important. Okay, that's what you have to do if you want to get it right. Now, if you don't want to get it right, I can't help you. Okay, you can do whatever you want if you don't want to get it right. So, we do 16 plus 3, which is 19. Then we do 19 minus 30. Now in this case, we're going to have to add integers, and the 30 is bigger, so we're going to be subtracting and taking the sign from the negative 30. So that's going to give us negative 11. All right, then we have negative 11 plus 1, which is negative 10. And we have negative 10 minus 1. Since those are the same signs, we add them together and we keep the sign, and you get negative 11. And that's your answer. All right. Now, hopefully, those 3 examples should illustrate for you how you should be doing this by hand. The other problem that I have, and this is a really, really common problem, the other problem that I have where people get this wrong is because they try to do it on their calculator and they're using the wrong calculator. Okay? So most of the time when people are doing this wrong on their calculator, they're using a basic calculator, or what I like to call a four-function calculator, because it has addition, subtraction, division, and multiplication, and that's about it. Now, the problem with these calculators is that if you're typing in something like this, the way that you see it, it's going to carry out each operation before going on to the next one. And we don't want it to do that. Okay? If you're just typing it in and expecting it to get it right, it's going to do it incorrectly that way. Because every time that you press a button on here, it carries out that operation. Okay? So if you type this into a calculator like this, it's going to get the answer wrong. Well, on the other hand, if you want to do this right, and you're not very good at math, and you want to use a calculator for it, what you really want to do is get one of these. Okay? This is a scientific calculator. And specifically, I have two brands that I recommend, or I should say models that I recommend, because you will see that if you are a nerd like me and you use a lot of calculators, you will see that even among the same brand of calculator, some are definitely inferior to others. Personally, I recommend the TI-30X2S or the TI-30XS. Okay, now the TI-30X2S looks like this, and it comes in a variety of different colors. But the thing about scientific calculators is that when you're doing any calculation, it's not going to actually carry out the calculation until you finally hit the equal sign. Okay? The basic calculator does each calculation as you put it in, which is problematic when you have complex expressions to evaluate. Okay? The thing I like about the X2S and the XS is that they also have a display screen. So, for example, if I wanted to do this guy, I can type it in, and I can actually see the expression that I've typed in. That's really, really helpful. Okay, so if you don't have one of these guys, at least get one where you can see what you're typing in. You can confirm that you're typing it in correctly. Okay? And if I hit enter here, you're going to see I get negative 11 on here, which is the correct result. Okay? If you do it on the basic calculator, you're not going to get that result because it's going to do it wrong. Now, a pretty reasonable question to ask is, why do we do this way? And the honest answer is I don't really know. Okay? It's convention. That's the way we do it. Okay? And these types of conventions have to be established and are important in mathematics so that everybody's doing it consistently. So that way, if I do a problem and I try to show you my work, and that's important in the math world, you understand how I got my result and why I got my result the way I did. And we're looking at the problem the same way. But I do have a hypothesis, okay? And my hypothesis is that it's because of physics, right? Specifically, in physics, we frequently have problems where you've got like a pretty classic problem where you have a block on an inclined plane, and you're looking at the acceleration of that block. Now, in physics, the acceleration of an object times its mass is equal to the sum of the forces on that object. So that big E symbol means the sum. Mathematicians like to use notation to make things shorter because we're lazy as heck. And so for a problem like this, if you were going to work it and you were going to try to find your acceleration, you'd have to identify all the forces on that object. And so in this case, we've got this string that's attached to our block, and that's applying force in that direction. We've got gravity, which is going down. But what we really care about for this problem is going to be the component of gravity in this direction. So that angle is theta, and then this force is going to be mg sine theta. And we also have a frictional force, which is going to be going in this direction, which is based off of a constant coefficient of kinetic friction, which is going to be mg mu cosine theta. All right, now I don't want to get too bogged down in the details here. The point here is that when we look at the acceleration of the object, we're going to have the tension of the string. We're going to call that F sub t. We're going to have the force from gravity, and we're going to have the force from the friction. And each of these is kind of a complicated entity in and of itself. And if we were going to write down the equation for this in this example, we have t plus mg sine theta minus, or let's just say plus, mg mu cosine theta. Now my point is, to get to the punchline here, is that each of these guys needs to be evaluated separately and then added together. Okay? That's what needs to happen. And if we weren't doing this with the order of operations, we'd have to put like parentheses around each of these guys in order to get it correctly. And in physics, you're doing this a lot. Like a lot. And sometimes you have a lot of forces. That gets really tedious, really old after a while. So that's my hypothesis. I could be wrong. I'm making things up here as far as that is concerned. Now, if you have questions about this, feel free to leave comments in the comment section below. And what I ask of you, if you found this video helpful, and you see somebody posting one of those things on the internet that everybody's getting wrong, and you see like, dozens and dozens of replies, post this video there so they can learn how to do it correctly. Because it really kind of makes me die a little each time when I see all the wrong answers on those threads. And I hope this was helpful to you. Thanks.